Presentation. If you would like to ask a question, please submit your question to me using the Q&A section of the Zoom window. Once the webinar has concluded, Jeff will answer the questions you submitted to the Q&A as time permits. And now let me introduce today's presenter, Jeff Cunningham. Jeff serves as a senior marketing coordinator at the American Galvanizers Association, where he plays a pivotal role in advancing the association's mission to promote the benefits of hot dip galvanizing. With over a decade of experience in the industry, Jeff is a recognized expert in the galvanizing process with a commitment to sustainability and quality. Now, Jeff, I'll turn the webinar over to you.
Awesome. Thank you so much, Betsy. I appreciate you guys having me here. My name is, Jeff Cunningham. I'm with the AGA, the American Galvanizers Association. So similar nonprofit trade association to you guys. And thank you so much for having me. I'm going to present today on the core galvanized seminar, pretty much our intro to hot dip galvanizing. We'll go over the process, projects, performance, design, a little bit of specification, and of course, inspection and sustainability as well. All right, so anybody on the call, we are accredited for continuing education from RCEP and AIA. So everyone on the call, later on, I'll email you a copy of a certificate of attendance for this as well. All right, so purpose of this seminar is to educate architects, engineers, other specifiers about utilizing galvanized steel on a myriad of projects throughout North America. You'll also be able to differentiate hot dip galvanizing from other zinc coatings. A lot of times we get lumped into other zinc coatings. And then identify reasons why specifiers choose galvanized steel. And then, of course, the positive environmental and economic contributions to the goals of sustainable development, which is critical in the world today. All right, before we really get started, I wanted to tell you guys also, I will send out a copy of the slide deck to anybody as a PDF, and every single one of these pictures has this little mouse icon here, and you can actually click to our website to get more information on all these projects. So we have our some of our PDFs and our publications as well as clickable. So you just be look on the lookout for that in the next couple of days. Learning objectives, you'll be able to complete or differentiate hot dip galvanizing for other zinc coatings, identify reasons, understand factors that affect hot dip galvanizing steel performance in various environments, and then, of course, goals of sustainable development. All right, just a little bit about the AGA. We are a nonprofit trade association established all the way back in 1933. So we've been around for a while. We have 76 different companies, 172 galvanizing plants throughout North America. So yeah, we're quite a big organization. We offer technical support, marketing support, and specifiers are a free resource for working on galvanized steel. All right, so first I'm going to start with structural steel. It's a just proven, durable, efficient building material, has always been used. It is reliable, resilient, and recyclable. So why do we use structural steel? Well, first off, it's readily available and reliable. It is cost effective because the galvanizing process is a very quick turnaround process, sometimes as little as 8 to 12 hours. And this causes accelerated construction schedules and therefore is more cost effective in time savings as well. It's highly resilient. We know high strength to weight ratio compared to concrete. Steel is about 1/6 of that to the concrete. Adaptable, you can, it's easily expanded upon, current steel structures. So it does make that future expansion way more capable. And then it also gives you design freedoms with aesthetic advantages. So we've been seeing more and more architecturally exposed structural steel projects, AESS for short. And those are using galvanized steel because they like the matte gray look. And then also it's recyclable. It's highly recycled. Pretty much steel is the most recycled material in the world. About 99.9% of steel out there is recycled. And then zinc, the zinc coating, it can be 100% recycled too without any loss of properties. So both zinc and steel can be 100% recycled, multi-cycled without any loss of properties. So what it really is a cradle to cradle material. You've heard cradle to gate a lot, start to end, but this is truly, once it gets to the end of life, it can be recycled without any loss of properties and then withstand another 70, 100 years in the same environment. So really sustainable building material. So first and foremost, why do we coat steel with zinc? Well, it is conquering corrosion. Corrosion is costly. According to a recent NACE study, who was formerly known as AMP, they did a global cost of corrosion is estimated at $2.5 trillion, which is equivalent to about 3.4% of the global GDP. Just 2.5 trillion worldwide, 659 billion in the US and 56 billion in Canada. There's also other concerns of just, it's a waste of natural resources if you build the structure and it crumbles to the ground in 20, 30 years. Can potentially create hazardous situations. We've seen a lot in the news about bridges collapsing and our crumbling infrastructure. Those are going to obviously have indirect costs. You're going to have to go out there and repair the project, sometimes just tear it down, restart, rebuild. Usually those indirect costs are about 5 to 11 times the cost of the direct project. Of course, you'll hear that public outcry. Everybody has their cell phone, everybody's taking pictures, everybody's posting everything. You're going to hear about some kind of huge failure due to corrosion. So that's why we have protective coatings. Now, not all are equal, and you definitely have to consider performance, cost, sustainability, and that sort of thing. Throughout this whole project, I'm just going to kind of pepper in some cool projects that, are latest excellence awards in galvanizing from the last couple years. So this is Metrolina greenhouse expansion. This is actually one of the this is the largest single-story structure in the United States, about 200 plus acres of greenhouses under one roof. And the inception was all the way back in 1972, but then they did a huge expansion on it in 2021. They chose to hot dip galvanized steel because, one, they're going to be in North Carolina, which is humid, corrosive environment. So they needed something to withstand the outside weather, but then also inside they use pesticides, fertilizers, chemicals to treat the plants. So they needed something to withstand corrosion from the inside as well. So they chose hot dip galvanizing because it gives that full exterior protection of the steel. All right, so next we'll talk a little bit about the actual galvanizing process. So this is just kind of an overview. The galvanizing process starts with surface preparation, which is absolutely critical because the part has to be clean in order for the iron and the zinc to react and form that metallurgical bonded coating. If you just dipped a random piece of steel you found without cleaning it, you're going to have a lot of bare spots because the zinc and the iron won't react. So that's why it goes through a series of surface preparation. It goes through a degreaser, dirts, oils, that sort of thing. Chemical cleaning is a little bit harsher. It's like a mill skill and oxides. And then the last part is a fluxing. Flux tank actually does two things. Cleans off anything that the chemical cleaning and degreasing didn't. And it also puts on a protective layer around it. So while it's drying, it won't pick up anything before it goes into that zinc bath. And then it's cooled and inspected. So a little bit more about surface preparation. It's just absolutely necessary as zinc will only react with the clean steel. Kind of went over these already. Yeah, jumping ahead of myself a little. Degreaser, dirts, oils, chemical cleaning, mill scale, oxide, rust, fluxing, mild cleaning, and then that protective layer so it doesn't pick up anything. Because once again, unclean areas will not grow that zinc coating and you'll have bare spots. All right, next comes the actual galvanizing process. So the steel is fully immersed in the bath of molten hot zinc, typically around 830 to 850 degrees Fahrenheit. Bath chemistry has to be 98% pure zinc according to ASTM standards. Now, every single galvanizer I know is running at more like 99.5, 99.6. Up to 2% additives include aluminum, bismuth, and nickel. And mostly that has no effect on the coating. It's just the fluidity of the bath. It keeps it a little bit more fluid. So pieces have a easier time going in and out. Then the molten zinc reacts with the iron to form a metallurgically bonded coating. Yeah, you're going to hear me say that a few times today, but it's actually fused together itself. It's not a mechanical bond where it's just kind of sitting on top. It's actually a mechanical bond and they're fused together, which we'll show you in a couple of slides. And then the reaction is complete when the steel reaches the bath temperature. Depending on how big the piece is, it could be as little as 2 minutes up to, 12, 15 minutes is all. All right, and then here's a video of the galvanizing process. Some of these, this is like a little bit of an older plant. A lot of times they'll have enclosures over the plant. So when you see that zinc kind of splashing up and stuff, it doesn't get anywhere. Right there, those guys are skimming off the dross and ash that kind of come on the top. Just kind of the stuff that burns off of the top layer of the steel and they brush it away. But then, yeah, it's a pretty quick process. And then you have galvanized steel, and as soon as it's cool enough to touch, it can be erected that same day. Inspection is scrutinized on all galvanized pieces, obviously, to conformance with specifications. Specification ASTM just dictates about adherence, coating thickness, and then any maximum bare spots. So it's usually just done with the inspection with the visual with the naked eye, making sure no bare spots or anything like that. You can get a coating thickness reading by using a magnetic thickness gauge. And then we have a whole inspection guide and an app. It's a free app for Apple and Google. What is nice about that is when you are in the boonies or don't have service on your phone, you can use our full app. And it just gives you a clear guide for surface conditions of galvanized steel. All right, so next I'm just going to talk briefly on what is zinc, natural, abundant, and essential to life. I think everybody kind of knows, obviously, zinc is important. It's a heavy or it's a healthy metal found in the ground. It's actually naturally found in the air, water, and soil. And 5.8 million tons of zinc are cycled throughout the environment annually. And everybody needs zinc. It's essential to life. It's vital for cell division, crucial for growth of bones and organs, brain development, memory, sensory, strength in our immune system. It's in pretty much everything. It's the 24th most abundant element in Earth's crust. You can find it anywhere from sunscreen, lotions, cold medicine, tires, door handles, car parts. Zinc's in just about everything you think of. And Zinc Saves the Kids is an initiative by the IZA, the International Zinc Association, and UNICEF, because over 500,000 people a year are zinc deficient, mostly in third world or developing countries. And a lot of those are children. And just $5 a donation provides one zinc tablet for an entire year to one child. So if you're thinking of looking back or giving back, definitely Zinc Saves the Kids is a great organization. This quote was from the International Zinc Association in 2022, and zinc from recycled sources has doubled between 2010 and 2019, while zinc production from mined ore has remained almost constant. So that means we're not mining any more than we need, but we're doubling the sources because we're recycling all this zinc. So it's a really good sustainable product. So there are other zinc coatings out there. I mentioned this at the beginning. Sometimes they get lumped in with hot dip galvanized steel or confused. So we just like to kind of lay them out there and so you know the differences. Here is all the zinc coatings, like a cross section. So starting from left to right is zinc thermal spray, and you have hot dip galvanized steel, zinc rich paint, galvanized sheet, and electroplated. Now you can see right off the bat that metallurgical bond, how dense and how tight that is. Thermal spray is close, it's about 85% as dense, but this is a good kind of to start to show that it's a thick coating and it's dense and that metallurgical bond. So zinc thermal spray is pretty much the closest you can get to galvanizing without galvanizing. It's also called metallizing. Zinc wire powder that's melted and sprayed onto the steel surface. Shopper field, you can do either. It's only about 85% as dense as hot dip galvanizing, and once again, mechanical bond, no alloy layers. There's no fused together, no metallurgical bond. It is quite expensive as well. Zinc-rich paint is mostly used for touch-up and repair. It's often falsely called cold galvanizing. There is really no such thing as cold galvanizing. Cathodic protection is just dependent upon what kind of conduitive binder they're using, zinc particles in contact, and percent of zinc and dry film. Once again, mostly for small touch-up and repair areas. Continuous sheet and electroplating are very similar. It's just minimal coating thickness, very thin layer of pure zinc. Electroplating is a little bit more expensive because they use electrodisposition. But once again, these kind of get lumped into galvanizing, but it is not hot dip galvanizing. It's very minimal, definitely a different product. If we put it on there, Galv Info Center. So if you ever have a question about continuous sheet, electroplating, any one of those zinc coatings, the Galv Info Center is where you want to go. All right, so why do specifiers use hot dip galvanizing? We'll go over corrosion protection, the durability, longevity, availability, versatility, and aesthetics. All right, so first and foremost, it is that long-lasting corrosion protection. You actually get 3 levels of corrosion protection in one coating system. First is going to be a barrier protection, because the barrier protection resists corrosion by just isolating that steel from the environment. It's a full immersion process, so every piece of that steel is coated by zinc, therefore isolating that steel from the environment. The second level is going to be cathodic protection. Now, zinc is a nodic steel and will actually sacrifice itself on the galvanic series of metals before iron will, to protect the underlying steel until all the zinc is consumed. So all the zinc needs to be consumed before the iron even starts to corrode at all. Next, and the most important one, is the third level of the zinc patina. This is zinc hydroxides and zinc oxides building up on the surface over time. All metals do create some sort of patina. You know, the most common one, copper, it kind of turns that green color. That's the patina developing, where it just naturally goes through wet and dry cycles, and it builds up this zinc hydroxide on the surface, and it really slows the overall corrosion rate, because it's like 99.9999998% impermeable from water. So it really resists the water corrosion getting in. So once that zinc patina develops, anywhere from a couple months to a year, depending on the environment, you're really going to lengthen that life of that steel. All right, this is a great slide to show you the metallurgical bond. This is a cross section of galvanized steel. And if you're looking at the chart here on the bottom, it's the base steel, which is 100% iron, and it says 159 DPN hardness. Since you guys are a metals organization, you might know DPN is just diamond pyramid number. It's a number they give to the hardness of a substance. So the higher the number, the harder the substance is. So if you look at the gamma, delta, and zeta, first off, they're all a mixture of zinc and iron. Gamma is 75 zinc, 25 iron. Delta is 90-10, zeta 94-6. So you can see that how they actually fuse together metallurgically. But then the DPN hardness number for all the gamma, delta, and zeta, all the alloy layers, is all above 159. So it's actually giving a abrasion resistance. It's actually harder than the base steel itself. So you also get that durability with the galvanized coating, as well as the longevity and corrosion protection. This is a good one for durability. This is the Cincinnati Zoo, the Elephant Trek. This is all kind of the inside. Used over 170 tons, frame structures, mesh, fence, window openings, holding areas, that sort of thing. Obviously, they needed something to withstand the elephants and these, thousands of pounds animals moving through here, bumping up against it, scratching, whatever. So they chose to hot dip galvanizing for the durability, but also it was the low to zero maintenance, because maintenance on these type of projects are so hard, because you gotta either close down the exhibit or half of the exhibit, you gotta move the animals. It's a whole thing other than just going and repainting a bridge or something. So they really wanted something to withstand the test of time and the animals bumping into them, and the durability. All right, uniform and complete coverage as well. I mentioned the interior coverage, and everything gets coated because it's a full immersion process, but you also get the same thicknesses at the edges and corners. because the coating grows perpendicular to the surface. So it's a chemical reaction, or it's a metallurgical reaction. So it's actually growing at every surface at the same amount. So you don't have, thicker parts on flat pieces, or, on the edges. You might, with paint or another coating system, it might be less. So you get fully, complete coverage. All right, this is a good one that we just worked on this last year. This is the Fort Wingate Bridge replacement project. This is in Gallup, New Mexico. And this is part of a press brake tub girder system that's kind of taken off for anything less than 100 foot span bridges in America. And it's a really cool, but it does require interior protection since it's a closed system. So they chose to hot dip galvanizing it since it does offer that interior protection. So it gave that closed system as well. If you are interested in press brake tub girders, I will refer you to SSSBA, it's Steel Short Spans Bridge Alliance, and they have been doing some great work. You can check them out online and stuff. I'll put in their website too in the chat later. We're gonna do a kind of go over our zinc coating life predictor. This is what we've been developing for a long time. Galvanized steel is a 150-year-old process. It obviously continues to get better and evolve. But what's nice about that is we have 150 years of real world data to go off of. We don't have to worry about salt spray testing. Salt spray testing doesn't actually reflect real world performance because it doesn't allow that zinc patina to develop. And the zinc patina is critical in that longevity for the hot dip galvanized steel. So when you're salt spray testing, it's not going to accurately mimic hot dip galvanizing in a real environment. So that's why we created the zinc coating life predictor. And this is off of extensive global corrosion data for the last 150 years on galvanized steel. Corrosion rate is dependent upon temperature, relative humidity, rainfall, airborne salinity, sulfur dioxide concentrate, and if there's a sheltering condition that exists. So when we take all of our data that we get from 150-year-olds all over the world, we get the time to first maintenance chart. Now it's important to define time to first maintenance as 5% rusting of the steel surface. So 5%, very minimal still, but might be time to first maintenance. Now, if you look, ASTM A123 on structural pieces requires at least 3.9 mils of zinc. Usually it's more like 5-6 mils that ends up happening on the thickness of a zinc coating. So if you're looking at, let's say 4 mils on a piece, and you're building in an industrial environment, one of the harshest environments to build in, time to first maintenance is putting it at 75 years. Now, it might be that the design life was only for 75 years, or it's beyond its design life, or you might get out there and there very well be not 5% rusting of the steel surface. It can last another 10-15 years. So it just kind of gives you off of real world data how long these can go. Some of the rural desert ones, I mean, it'll last a couple hundred years if you let it. So just kind of gives we have all this available on our website too, and we do a cost calculation later on as well, and using our cost calculator that takes that all into consideration as well, and you can use that free on our website as well. Longevity in soil, we're going to talk about just kind of a couple different areas. It is a little bit difficult to predict. There's just highly varying properties within soil. You can have changes in short distances. You can be working with, rocky soil on one side and a soft clay-like soil on the other of a bridge, something like that. Soil, it comes down to primary and secondary factors of, corrosion rate is going to be chlorides, pH level, and moisture content are your primary factors. Secondary factors are restivity, temperature, and aeration. And then we have built this soil chart that uses real world data to estimate the full service life based on those primary factors. So once again, you pull up our little handy soil charts here. And if you determine, if you're working in high or low chlorides, or a high or low pH or high or low moisture, then you can figure out which chart you're on. But just for demonstration, we'll say we're working in low chlorides and a high pH. We're going to be on chart 3. And then, of course, about 4 mils is a good estimate of zinc coating. Anything in the red is less favorable. Anything in the green is more favorable. Still looking at over, 70, 80 years in that kind of soil. Once again, these are all free on our website. Definitely check them out. Longevity in water, similar to soil, it is just difficult to predict. Changes in water, flow rates, impurities introduced. Primary factors are going to be similar: pH level, agitation, aeration, temperature, polarization, and presence of inhibitors. Freshwater, a good rule of thumb with that is hard water is less corrosive than soft, just because of the added chemicals they put in soft water. Seawater, you want to look at dissolved salts and passive compounds, and then a good rule of thumb with that is just the lower temp seawater, the less corrosive it's going to be. We do have a whole page on in water. So, we've worked on a lot of docks, piers, marinas, that sort of thing. So if you're, interested in that kind of stuff, definitely contact us and we can help you out. I like to put up this slide, just good performance versus corrosive. Good performance for hot dip galvanizing is anything with a neutral pH, 4 to 12.5. Treated wood can only be said with hot dip galvanizing and stainless. Does great in concrete. Hot dip galvanized rebar is it actually protects the concrete from outgassing, sprawling. It's incredible. We actually offer a full hour on reinforced steel, and it's about 6 times it'll last as long than just black bar. Works really well with extreme temperatures, all the way from -40 degrees Fahrenheit to 392. And then it works with aluminum and stainless, except if you're right off the coast, like really salty air and stuff like that. Corrosive to hot dip galvanized steel is highs and low pHs, and then in contact with dissimilar metal. Most of the time it's fine. You just want to isolate with a non-conductive material, rubber, cement, paint. Just have to consider the, how much of the surface area is in contact, and then, what kind of environment. This is a good longevity project. This is Frederick Myers Botanic Gardens. It's built in Grand Rapids, Michigan in 1994, and just won our most distinguished award a few years back. The architect really needed something that withstand, Grand Rapids, Michigan. Weather is, 9 feet of snow every year. 90, 120 mile an hour winds, rain, you name it. But then also like the Metrolina one, they need to, protect the inside of the structure as well from, pesticides, herbicides, all this stuff that they use to treat the plants. So they chose galvanizing. We went back in 2018 and shot this video. It honestly looked the day as good as it was the day it was. We took a few sample readings around, just walking around, and the lowest one we could find was 5.2 mils. And that's after 30 years in Michigan's weather. So I'm just saying there's a, hot dip galvanizing steel can, last a very long time. All right, it is available. It's factory controlled. There's no humidity requirements for galvanizing. So galvanizing can be done 365 or, 24/7, 365, rain or shine. Galvanizers throughout North America, right on the top of our website, you'll see a galvanizer locator. And you can put in your zip code and mile radius and contact information. Many are about 40 feet in kettles, although some are about 50 or 60 feet. And honestly, they can fit pretty much anything in a kettle. They can also do it as a progressive dip, where they dip it in one side, turn around, dip it in the other. I've seen it all. Quick turnaround time, like I mentioned, no curing time. So as soon as it's cool enough to touch, it can be erected the same day. Variety of pieces, intricate pieces up to large structural fasteners, small parts that, the footballers, that's the statue right there. That's all galvanized and came out great. You can do more with less. It does have that high strength to weight ratio of that to concrete. Steel to concrete is about 1 to 6. Ease of expansion. Most of the time, since galvanized steel lasts so long, a lot of galvanizers will have just inventory and stocks on their yard. And then it does better in seismic advantages. Steel is just more ductile and lighter than concrete, so it's obviously going to do better in seismic activity. You get that modern natural appearance. It will weather out to that matte gray, kind of blends in with your surroundings. It is non-reflective. And design freedom, we have been seeing more AESS structures or AESS projects coming up. The architecturally exposed structural steel, kind of using the beauty of the steel in the architecture. Sometimes just meeting ASTM A123 does not meet the aesthetic desired for AESS, so you just have to have a initial or a discussion with your galvanizer and how they can make that as pretty as possible. All right, this is we get a lot of questions about weathering. Like, oh, I got a piece and half of it was shiny, half of it was dull. Like, what's happening? And it's like, no, there's nothing wrong with the corrosion protection, nothing wrong with it. It will just weather out. So if you see the photo at the top left was taken December 18th, 2022. And then the photo taken of the same guardrail March, just 3 months later, and you can see it already all weathered out and looks the same. Same with the bottom below as 2019. You can tell that brand spanking new one was sitting next to that older one. And then 5 years later, they have, both looking exactly the same, weathered out. So we have more examples and stuff of the natural weathering of galvanized steel if you're interested. This is a great AESS project, and I highly recommend if you're in New York to go to Monheim Station. It was completed in 2020, and they just used galvanized steel for the beauty of the arcs of the truss and everything. And obviously, New York, pretty harsh conditions, corrosive environment. So obviously, they needed something to withstand the test of time, but then they liked that they didn't have to go out there and maintain it. It was just going to be. So they wouldn't have to shut down part of the station. One of the busiest train stations in all of New York. So once again, I definitely recommend going to see it. It's quite a feat. All right, so sometimes if you don't want that matte gray, you want some color. And that's why we offer duplex systems. Duplex system is a paint or powder coat over the galvanized steel. We've seen it done for many times. It's mostly just aesthetic preference. Sometimes it's branding, matching, safety identifications. Maybe you have to, a gas line or something like that. Or a lot of times it's used to repair existing structures. What happens when you paint or powder coat over galvanized steel is it actually provides 1.5 to 2 times the sums of the systems alone. And it also extends the maintenance cycle. If you think about it, the paint or powder coat is going to isolate that galvanizing from the environment, lengthening that life, as well as the galvanized steel actually protects the paint or powder coat from underfilming, bubbling, gassing, that sort of thing. So it actually works together and provides that longer life. This is a good one that we just completed in 2023 in Pittsburgh. It was their Highland Park interchange project. And this is 500 tons of steel, all large and small beams, columns, and then galvanized and then painted afterwards. And they wanted something. It was a kind of a highway divider interchange project. Obviously, sound barriers was very important, but then they kind of constructed it to look like the Allegheny River, which it's right next to. So that's kind of the waves going through it. And then they wanted to paint it kind of an off blue to kind of mimic the river. So that's their deliberate choice for using a duplex system, but obviously it's going to lengthen that life. And Pittsburgh, a pretty harsh climate as well. All right, I'll just talk a little bit about hot dip galvanizing steel's sustainability, environmental, economic, and social, and then we'll also do a life cycle cost calculator to run through as well. All right, so economic advantages are, both iron and zinc are natural and abundant materials, both essential to life. We need them in order to live. Iron ore is the 4th most abundant element, and zinc is the 24th most abundant. Infinitely renewable. Both are 100% recycled. They can be multi-cycled without any loss of properties. We worked on a project where it was a bridge in Haiti and, a bridge in Massachusetts that had been in service for 25 years. They galvanized steel, they ripped it down, recycled, regalved everything, no new material, shipped it down to Haiti when they had a hurricane and they needed to repair one of theirs. They put it right up. The whole project from start to finish only took 6 months, and literally the cost savings are just astronomical for reusing that. High reclamation rates, steel virtually 100% recycled in the world. Zinc, about 80% of zinc that is available is recycled, and that number continues to climb as well. And of course, it just offsets that maintenance-free longevity. This is one of the best projects we have, I think, and one of the most sustainable. This is the Mr. Professor and Captain Trash Wheel. They're built in Baltimore, Maryland. Back in 2014, they debuted, and what they do is they just go around the harbor and they use the water wheels and they use these like little rakes, and they just rake up trash. Since their debut in 2014, 1.5 million pounds of trash have been picked up. There's 3 of them now. I think they just added a 4th. They become local celebrities. This one has googly eyes in the video. They have maps that, or a website that tracks them, so you can see. And I don't know, I was on there like last year, and I saw one all the way down in like all the way almost close to Florida now. So they just go up and down the coast picking up trash. So I thought it was just a really cool idea, but they use galvanized steel and you know, in the water wheel and all the conveyor belt and stuff. This is another great sustainable project. This is the Howling Heat Recovery System. It's in Mona, Utah, and this is a great idea. I'm not sure the architect who thought of this, but this is adjacent to a power plant. So they built these huge pipes, and these pipes house all of the tomato plants, and they use the heat from the adjacent power plant and the CO2 emissions to feed the tomato plants, and also make the, you know, the heat and feed them, make it a whole sustainable as a win-win, as it offsets their emissions as well. So I really hope more of these projects come up, because it's, you know, great way to offset emissions from, you know, a huge power plant. All right, now we will go through a you know, economic advantages, and then we will do a life cycle cost calculator. And these are all automated for you guys at lccc.galvanizer.org. It's really great. You get to choose all your coding systems, you know, how big your project is, parameters. We'll go through one, and then you get a nice printout at the end of all the different codings and costs and stuff like that. So it will go over initial costs, you know, and then life cycle savings throughout the project. And then you will see that often hot dip galvanizing initial cost is its actual life cycle cost, because it just lasts so long. You don't have to go repair it. All right, so here is our cost case study. We're going to be looking at initial cost parameters, our material and number of coats, surface prep, cleaning methods, or shop or field. And life cycle cost parameters are going to be maintenance costs on particular cycle. It's dictated by that manufacturer. And then we use net present value and net future value for inflation and interest. All right, so here's what we're working on today. We are going to build a 50,000 square foot project. We're using typical mix of sizes and shapes. We are looking for a 70-year design life. We're building in a moderately industrial environment, a C3. Surface prep and application are SB10 automated. Duplex would be SB16. And all coats are applied in the shop. This very well could be a parking structure, a small petrochem plant, a small stadium, something like that. So this is, once we put it into our life cycle cost calculator, once again off of real world data, this is our initial cost for our system. Once you, right off the bat, you see hot dip galvanizing comes in at $2.16 a square foot, just over $100,000 for the initial cost. I do like to point out on this one that the second to the last one, the HGG plus epoxy polyurethane or duplex, comes in at $6.65 a square foot. I just want to keep that in mind when we look at the full life cycle cost. So the full life cycle cost, 70 years, hot dip galvanizing does not change. We don't need to go and maintain it. After that 75 or 70 years, we can either tear it down, recycle it, build it again, but we do not need to maintain it. So therefore, our whole entire life cycle cost is $180,000. Now you can see how all of the paints have exponentially gone up because you're looking at maintenance cycles every 5 to 8 to 10 years, depending on the manufacturer. Sometimes there's a full repaint if it's longer than 50 or 60 years needed. So those are why it adds up really quick. But now if you look at duplex, hot dip galvanizing epoxy polyurethane duplex is only $15.60 cents a square foot, now making it the second most economical because excuse me, because hot dip galvanizing protects the paint. It can extend those maintenance cycles by 1.5 to 2 times, sometimes even losing a full repaint and losing a maintenance cycle altogether. So once again, these are available on our website. It gives you a nice, really nice print-off PDF when you're done with putting in your project parameters. But highly recommend it if you guys are working on something or want to see the differences between hot dip galvanizing and the rest of the coatings. All right, so in summary, why do we hot dip galvanizing? Well, it's just proven performance. It continues to evolve. 150-year-old process, and it just keeps getting better. It's made from a natural, abundant, recyclable materials, zinc and steel. And then, of course, unmatched corrosion protection, durability, maintenance-free longevity, availability, versatility, aesthetics, and environmentally and economically sustainable. We did just launch this last year our new markets website. This is highlighting all the BIL, the Bipartisan Infrastructure Law Act. We're finally starting to see some of that money trickle down to our galvanizers and whatnot working on infrastructure projects. So this website, it's markets.galvanizing.org. It highlights all of the different parts of the infrastructure and then highlights in these cool little, the GIFs that play or these little graphics. Everything blue in there is what can be hot dip galvanized steel, and you can click into it, find out a little bit more. Various animations highlighting all the various uses of hot dip galvanized steel. So thought I would do a little plug there and check it out. Just a little couple of resources for you guys. Biggest one is just our email, aga@galvanizing.org. If you ever have a question, want to, reach out, have a random question about metallurgy too. We have, our whole technical staff. We have engineers on staff, we have chemical engineer, corrosion engineers. So they're willing to help, and it's all a free resource for you guys. And if you guys haven't already, I highly recommend signing up for our Galvanizing Insights monthly newsletter. And then we have a technical library that's available for free. All right, Betsy, that brings me to my end of my presentation. I know you wanted to go ahead and announce this one, and then maybe we can field some questions.
Yes. So let's go to the questions first so we can be sure and get everybody's questions. Walter, so we have.
I'll leave up my our contact.
Okay.
For the questions.
Perfect. So we have 13 questions, 14, 15. We just got 2 more.
Okay.
We're still coming in.
Okay,
I'm not trying to get to them in order. Walter asked, we do a lot of powder coating over hot dip galvanizing and find it very time consuming to clean air-cooled material. We have recently tried acid etch material, which seems to be working with the powder coating. Is there any downside to this?
No, I don't think so. We've heard a lot about that now. It is a time consuming because you got to outgas it, you got to bake it. Like it's a process. It's not just paint it and go. The treated the acid etch material, we haven't seen any kind of cause for concern or anything with galvanized steel. It seems the way to go. It seems to quicken the process a little bit. But yeah, most of our galvanizers now, the newer plants are all in-house. So they'll just have a galvanizing line and then send it over to their powder line. So it's all in-house and makes it really convenient. So yeah, if you come across any kind of issues though, Walter, I definitely recommend you reaching out to us and letting us know.
Okay, next, Tony has a question. What should one take into consideration when galvanizing cast parts?
Sure, cast parts. So you just want to make sure to thoroughly clean it. I think like sometimes embedded sand and stuff like that gets caught. You just want to make sure the part is completely clean, and then you should be able to galvanize no problem.
All right, next question. Greg asked, are there better options to powder coating for aesthetics over the HDG?
Sure. We've gotten this a couple times. No, not really. So there, a while back in the 80s, I think some galvanizer came out with color galv, and it was supposed to be like, ooh, it's galvanizing, but you can add a tinge of green or blue. And it fell flat because you can't add stuff to the zinc, or if you add too much stuff to the zinc, it won't bond together. So that's why we just say, nope, galvanize it, then paint or powder coat afterwards if you want color.
All right, Walter had another question. Why don't they use galvanizing on bridges more often?
Well, we'd love to. I mean, that's one of our that's one of our things. If you go to the National Bridge Inventory, I think there's over 400,000 catalog bridges in there. It's I think we're fighting a little bit of the cost. If the main thing to build this bridge is to keep the cost down, they're gonna just quick paint it, and we're seeing that when it comes time to maintain these bridges that have been painted and stuff, they're just not. They just say, no, it's whatever. We'll go repair it in 20 years when it falls apart. So we're kind of fighting that in the market. It's also a speed thing. Sometimes they don't want to, the fabricator has the steel ready to go. They want to ship it to the job site instead of shipping it to the galvanizer to galvanize and then to the job site. So sometimes that's a hang up. Weathering steel has been kind of chipping in at our market share, which now weathering steel is a big product in the 70s and 80s, and now we're finally starting to see weathering steel fail. But then when somebody says, oh, that steel bridge failed, how many of the common people are going to know the difference between hot dip galvanizing, painting, and weathering? So they just hear steel and they go, oh, geez, it's all steel. So there's a lot going on, but that's one of our main drives is to more galvanized steel bridges or more infrastructure related projects.
Okay, Jay asked, what do the additives to?
Sure.
What do the
It's just
additives do?
mostly for the fluidity of the bath, so that if so people think they see this molten hot zinc, it's actually like hard, like you couldn't push into the zinc. Only like the heavy steel being lowered in actually goes in. So it kind of helps out with that. It's a aluminum business and nickel, but it has no effect on the coating whatsoever. And like I said, most of the galvanizers are running at 99.5 or higher percent zinc. So mostly zinc, but it helps out with that little bit of fluidity of the bath.
Okay, Greg asked, what is the best touch-up to welding galvanized steel in the field?
Sure. So we have a wealth of information on welding. So a couple different things. If you have a weld that's hot dip galvanizing and it's in the field and you're repairing it, typically just zinc rich paint. You can metallize that sort of thing. But if you are galvanizing and then or welding and then galvanizing, there's a few steps to take. You want to look at your weld rod chemistry is as close to as your steel chemistry as possible. Silicone and phosphorus act as a coating accelerant, a coating growth accelerant. So high silicone steels, high phosphorus steels might have a little bit extra coating. So you want to match that with your weld rod. If you're welding before, you want to leave 3/32 of an inch. So you want to do stitch welding. It just kind of depends. I mean, there's a ton of different welds out there, and welding hot dip galvanized steel. We have a whole publication on it. So if you just go to our website, type in welding, you'll be able to find a wealth of information on that.
Okay, inclusive blacksmiths ask, would painting or another coating over galvanizing for aesthetic affect the zinc patina or the overall effectiveness of the coating?
Yeah, I mean, it doesn't allow that zinc patina to develop, obviously, because it's covered up, doesn't have the wet dry cycles, whatever. But you're not going to see any kind of interference with the longevity of the corrosion protection, because that paint is protecting that galvanizing. The galvanizing is actually protecting the paint. Therefore, when you go to repaint or touch up and repair, it's very small areas that you're touching up and repairing. You're not having to restrip and do the whole thing. So, yeah, I mean, we offer a duplex seminar as well. It goes into a whole, surface prep through, installation, all that. So I highly recommend checking that out. We actually have a webinar tomorrow at 2 p.m. as well, for a duplex system. So definitely check that out on our website.
Okay, Jeff, just so you know, we have 10 more questions.
Okay, wow. All right, keep them coming.
Inclusive Blacksmiths also ask, will galvanizing also fully protect interior threads?
Correct. Yeah, fully coated threads. They're just centrifuged or spun to remove the excess zinc. Most of the time, like the male will protect the female. You can over tap nuts a little bit, just accounting for that extra pickup, that extra coating thickness. But yeah, it's done all the time.
All right. Tony asks, what type of welding wire or rod is best to use when galvanizing to minimize weld swelling after galvanizing?
Sure, yeah, swollen welds, yeah, that's mostly like a high silicone or phosphorus weld rod. We'll get those swollen wads, so watch out for that. But mostly just matching the steel chemistry is the best, because then if you match the steel chemistry with your weld rod, you're going to have the same coating growth on the non-welded area and the weld. So just watching out for that steel rod chemistry is probably the most important.
Okay, Walter asks, our galvanizer tends to warp longer pieces of material. How can we limit this? Should it be lifted at certain places and spacing?
Yeah, you can try, spacing out or putting in extra lift points on the piece. Ask them about their laydown, if they're, if it goes directly into the yard, if it lays down and cools and then goes somewhere. Sometimes that affects it. Also sometimes it's just you'll have inherent stresses within the steel already from the fabrication. If you're cold working, if you're bending, if you're doing anything like that, the heat from the hot dip galvanizing will relieve those stresses. So you'll see the little bends and stuff. There is an ASTM safeguarding against warpage and distortion specification, and those have some good design tips in there. So I would check out that.
All right. We have another question. How was the footballer sculpture vented?
So yeah, good question. It was vented. So let's see if I can just go back there real quick. The holes were actually a lot larger than what you see here. And then afterwards they were plugged up. So all of these holes were a lot larger. So it really came out clean. Like there wasn't a lot of drainage issues at all. So, but yeah, no, we get that when people see it. They're like, well, where did all the zinc go? But no, yeah. So they just they can plug them up afterwards.
Okay, Aaron asked, is there any way to keep a spangled surface like on slide 15 or a shiny finish, or does the HDG always go dull over time?
Yeah, it's hard. It's gonna dull over time just with the zinc hydroxides opening or forming on the zinc patina. Yeah, that spangled look, it will eventually go away. I've seen pieces that it'll stick around for 10 years or so. It's just hard to say. The galvanizer also has no control over it. You could be doing the exact same pieces and one's spangled and one's not. It's just kind of a one of those conundrums of zinc.
All right, Peter asked, what type of paint system or paint formulation do you recommend?
We go off of KTA Tater. So KTA Tater has a list of paint or powder coat that they recommend using for hot dip galvanizing. So definitely check KTA Tater for more info on there.
Aaron asked, we add 4% extra weight when parts get HDG, but sometimes the weight ends up more. Is there a better calculation for the extra weight?
Yeah, I mean 4%'s a good starting point. I would ask your galvanizer. They would be able to tell you a lot. I mean, they're keeping track of weight like crazy because they need to know how much zinc to order and how much zinc's leaving their plant and stuff like that. So they should be able to help you out on that.
All right, Brayden asked, does metallizing fall under your organization, or is there an organization that specifically researches it?
Sure. No, it does not. So it falls under that Galv Info Center. And then the International Zinc Association have done a lot with metallizing as well.
Peter asked, we have a lot of components that are only available in cast iron. How can we improve galvanizing finish on cast iron parts?
Man, I don't know if I've had a cast iron part, because cast irons technically it already has a coating on it, correct? So I'm not sure. You know what? That's a good one. I kind of want to look that up myself. Let me get back to you on that. And I can get that over to our technical department.
Looks like Peter won the prize for stumping the presenter.
I know, yeah, hey,
Congratulations.
yeah.
Okay, we have a couple more. Mac asked, do you know if the Sculpt Nouveau metal coating paints can be used over galvanized steel without causing corrosion from the dissimilar metals?
I'm not an expert on paint, so I could not tell you one way or the other if the metal coating paints would work or not. So, if you mention that to the manufacturer of the paint, they should be able to tell you. But yeah, once again, geez, another one. I'm not a paint guy though, so that one doesn't count.
All right, we have another cast iron question from Susan. We find that cast iron castings can crack in the hot dip galvanized process, especially the larger pieces. Cast steel pieces are fine. Do others on I guess she means, do others on the webinar find this as well? You already commented that cleaning the cast pieces is all you need.
Oh, okay. So you're just talking about casting. For some reason, I was thinking about cast iron like a skillet or something, and I was like, wait, that already has a coating on it. Okay, all right, that makes more sense. Yeah, castings. We have it is kind of tricky. We do see more kind of issues with castings and stuff. I want to see if I can't find some information on castings on our website, because we have some like mostly is going to be the sand embedded rough bare spots and stuff like that, but I'm not sure about the cracking part. Yeah, I mean it might just be residual stresses. Is it thick and thin material together? Thick and thin material definitely has a chance to warp or distort or crack, just because one, it takes a while for the thicker part to heat up than the thinner part. It could be several types of those issues that's going on. So I would be interested if you want to email us aga@galvanize.org some more info on that. I would love to get that over to our tech team and see what they think.
Last question from Philippe. Since you can't visually check that, how can you make sure the zinc goes all over the interior of hollow shapes?
Sure. I mean, most of the time you can peek down a guardrail and stuff, but yeah, I mean, there is, you're making sure that the steel is properly cleaned. A lot of times on the hollow pieces, they'll go through the surface prep twice. So they'll go through once, come back out, go right through again. So they make sure that there's going to be no bare spots or anything. But since it's a metallurgical bond and a metallurgical process, you know that when iron is going to be dipped into the zinc, it's going to start growing that coating regardless. So it's just making sure, taking that extra time to make sure those pieces are clean, and then you can count on it being interior coverage as well. But no, good question.
Okay, we have one more question that slipped in. Jay wants to know, what are some questions to ask before choosing a galvanizer?
Sure. I'd ask about, do they work with a fabricator? Sometimes if you get the fabricator involved on the project, things go a lot smoother as well. Ask them about, I know a lot of galvanizers are busier than others, so ask about, turnaround time and stuff like that. If you're doing any kind of duplexing, it's a very important question to ask of who is in charge for surface prepping after galvanizing, because surface prep after galvanizing, sometimes you need to roughen up the surface to get a good anchor for the paint. What we talked about, powder coating with the outgas, baking and that stuff. So just really, roles and responsibilities for everybody throughout the whole project is a really good way to start a conversation with the galvanizer.
Wow, thank you, Jeff. You're a wealth of knowledge. So thank you for
Oh, thank
presenting
you.
today's webinar, and thank you to all the attendees for
Absolutely.
all your great questions. That was really good participation. So
Absolutely. And
this
then here, let
webinar
me
is
go back to that next slide for you. I'm sorry.
okay. Yeah, so this webinar is part of NOMMA's new webinar series. So please check the community events calendar on the NOMMA website. It's under events calendar for a listing of upcoming webinars and other events. And your feedback is really important to us. So we'd really love for you to complete our very, very quick 3-minute survey. And if you do so, we will give you a $5 discount off our next webinar. And I did put the link to that survey in the chat window, but I'll also send it again to you via email to the email address you indicated when you registered. And so take advantage of that $5 off. That's going to go towards our next webinar, the good, the bad, and the ugly. Economic forecasting for the metals industry. And it's on November 14th at 2 p.m. Eastern. And so this concludes our session. Thank you all. Thank you, Jeff, and everyone have a great rest of your day.
All right. Thank you, everyone.